used against you in a court of law. Well, maybe not in a court of law, but on a math test. Okay? So this chapter is all about functions, linear functions, graphs of functions, and and graphs of linear functions and graphs of nonlinear functions, some nonlinear functions. Okay? And this is section 2-2. Okay? And this section is called functions. And so we're going to spend kind of two days on this part. And so we have quite a few PowerPoints slides on this, but this is an example of a function. Does anyone know already what a function is? What a function is? Jessica, of course, knows. What's a function, Jessica?
I'm pretty sure it's something that takes an input.
Yep.
Well, depending on what the function is, it does something to the input and an output.
Perfect, okay? So a function is something that you put something into. You have a kind of a visual on it coming up, okay? But you take something, you put it in, okay? So here's the function, which a lot of times they'll call like f of x. So I'll talk more about this in a minute. You put something into that function, it kind of chews this up, and it spits something else out, okay? That's what a function does. So in this case, usually what you put in is like the x value, and then you get out some y value, okay? So you put in the x, you get out the y. And we'll talk more about what those words are called and all that. So one type of function is this is one particular function in which this is time and this is temperature. So with this, it appears what appears to be happening over time in this function. What's happening to the temperature over time? It's going down. Whatever this is a function of, maybe this is putting a popsicle into the freezer or something. I don't know. Or maybe it's your body temperature as you jump into a lake. No, that would be really cold, huh? Because 30 degrees. Maybe freezing. I'm not sure what it is, but it's a graph. This is a graph of a function. And we'll talk about what makes a function in a minute. Okay? So, what makes a function a function? For each x value, there is exactly one y value, okay? For every x value, there's exactly one y value. So that's part of what makes a function a function. So you can't have, so a lot of times with functions, they'll have, okay, here's some x values over here, some y values over here, and they'll make a little table, and they'll say -3, you put it into some function, you get out 2. -6, you put in it to some function, you get out 1. 4, you put it into some function, you also get out 2. Okay? This is a function because for every x value, if I were to graph these points, -3, 2 would be here. -6, 1 would be here. 4, 2 would be something over here. For every x, there's exactly one y value. Okay? But you can't have two different y values for one x value. So if you saw something that looked like this, if you put in a 4 and get out a 2, and then you put in a 4 and get out a 3, that immediately tells you that this is not a function because there are two different y values for one x value. You could have different x values and the same y value, like over here, but you cannot have two x values giving, or one x value giving you out two different y values. So you have to get rid of that one in order for that thing to be a function. Yes? Got it? Okay. So we're going to move on to the next slide. Okay? What does it say? That's not the next slide, is it? Is that the one I just looked at? No. Okay? So the next slide, think about this in terms about the function defined in terms of graphs. Okay? This is a function. This is not a function. Anyone tell me why? That is true. Ian?
Well, because for each x value, there's two y values.
Right, for each, so like over here, for this x value, for example, there's one y value, two y values. For this x value over here, there's two y values, right? For, yes?
Just wondering, wouldn't the one on the right be maybe a graph for an absolute value equation or something?
No. I mean, it has an equation, but that equation wouldn't be a function. So this equation would be like x equals y squared, okay? If I were going to graph that. But don't worry about it. Right now, you just have to worry about this is not a function. This is a function because for every x value, there is exactly one y value. And even though in some cases, that y value is the same. You understand? Okay? In order for a function to be a function, it has to pass something. Remind me in what? Postpone. So, my computer's going to blow up in the middle of my lesson. Okay? So, in order for a function to be a function, it has to pass something called the vertical line test. Okay? Have you heard of that? If you take a line and you draw it, and if that line, that's not a very good line. Let's make my line thicker, okay? I can make it a not dotted line. And I can make it thicker, okay? If I take a line and I draw it straight down, and this line only crosses that function in one spot, okay? Or it only crosses that curve in one spot, anywhere I drag that line, then it is a function. It's called the vertical line test. So if you take your ruler and you bring it across, and it only crosses in one spot wherever you bring it, then that thing is a function. So is this thing a function? Yes. Does this one over here pass that same vertical line test? No, right? Because it crosses in two spots. Get it? Okay? Doesn't cross the vertical line test. Isn't that cool, the way I could do that with my little vertical line? Okay? So we'll talk about that. I think we talk about that in the next slide. Okay? Vertical line test. A graph represents a function if a vertical line intersects the graph only once. You should write that down. Okay? What? Where's my vertical line? So let's draw in a vertical line. There's a vertical line. There's a vertical line. Therefore, this one here is, this one here is, where did my vertical lines go? Go back. There. So this one here is yes, and this one here is no. Right? Not a function. Yes? A function. No, not a function. Questions about that? Easy enough? All right. Got it? No. No? You want me to wait? Okay. Ready to go?
Yeah.
Okay. Thank you. Who said yeah? Thanks, Ian. All right. So vertical line test. So out of these two, can you tell me if this is a function? Hannah, is this a function? Hannah, is this a function?
Yeah.
Yes. Does it pass the vertical line test?
Yeah.
Yeah. Okay. Jacob Burns, is this a function?
No.
Why not?
Because it
Well, but specifically, why not though?
doesn't pass that.
Right, if I took a line and went like this, right, we would cross it in two spots. That's vertical, by the way. There's nowhere I could make this cross this thing in two spots, right? But, so the answer is for this one, it is, what happens when I do that? I think I just have to go back, and I can say that this one is yes, and this one is no. Okay? All right, let's move on. What's next? Is this a function? Function or not a function? Would it pass a vertical line test? Yes, okay. This, by the way, is called the discrete function. You don't have to know these words yet, but this is called discrete, okay? If you're wondering, meaning it's made up of a set of points versus a continuous, which is when it's every point in between, okay? So this is a discrete function, meaning it's made up of dots, where a continuous, it would be connecting all the dots, okay? Just so you know, but that could be a function too. So with ordered pairs, here's a list of some ordered pairs from that graph, okay? This is the x value from the graph of this is a temperature thing, okay? These are the x values. These are the y values, okay? There's something, this has a name, and this has a name, okay? And I think the next slide tells you what those names are, okay? So the set of all the first coordinates is called the domain, okay? And the set of all the second coordinates is called the range. So the x's basically are called the domain. Whoops, I have to draw this out. You should write this down, okay? Let's see if you can get it all, if I can fit it all on the page. The set of all these second coordinates is called the range, and all the first coordinates is called the domain. So this is the domain. Domain, right, is the set of all the points 0, 1, 2, 3. Okay? And the range are the possible y values, which in this case are 30.6, 30.4, 29.2, and 30.1. Questions about that? I'll let you write that down. Whoops. While I pause. I'm going to pause. And then our viewing audience will be very disappointed. Who can tell me what is the domain of this set of points? These are points. 1, 2, other than Jessica. Allie. 1, 3, 5, 7. What's the range? Ellie. 2 and 6. Do you guys get that? Okay. So, and sometimes they draw it with arrows as well. So they might say 1 goes to 2. Okay. 3 also goes to 2. Okay. 5 goes to 6, and 7 goes to 6. Okay? So I don't know what that particular function is, but if you plug in a 1, you get out a 2. Plug in a 3, you get out a 2. If you plug in a 5, you get out a 6. And if you plug in a 7, you get out a 6. We're going to do a game in a little bit where you have to figure out what that function is. That's the kind of fun thing. Okay? All right. Next. Will. Don't die on me here, okay? You can do it. Did we do this? Oh, did I skip a slide? Domain, oh, what's a domain? What's a domain, Chase? 1 and 5. What's the range? 2, 3, 6, and 7. Is this a function? No, because 1 gives you out 2 different values. Come on. 1 gives you out 2 different values, okay? 1 could give you out a 1 or a 2, or 1 could give you out a 3. 5 could give you a 6 or a 7. So this is not a function. Sometimes they call this, instead of calling this a function, you might see in your homework the word correspondence. Okay? It's a relationship, but it's not a function. Correspond, how do you spell that? E-N-C-E. It's a correspondence. It's a correspondence, but not a function. Okay? The domain is a set of all x values, and the range is a set of all y values. Do you guys know that already? You should know that. Okay? Domain is a set of x values, range is a set of y values. Write that down. Write it down. Writing it down helps you remember things. It really does. I kid you not. Because we can't wait for you here. Okay? Okay. Going on to the next thing. So these are kind of tricky. They want you to state what is the domain. What's the domain of this function? What's the domain? What are the possible x values? Amanda.
-3, -1, and 5.
Well, it's not just those points, but it's all. So when you look at the domain, what you kind of want to look at is all the possible x values, not just those points. Yes, it goes through those points, but all the points in between, since it's a continuous function, all the points in between are included. All the x values. One way to think about that is to kind of think of a lamp shining down on the function, and its shadow is on the x-axis. Okay, so if I were to take like a flashlight or something, I'm not a very good drawer, but if this is my flashlight pointing down, and the light went down there, where would the shadow fall? Where would the points on the shadow fall? From where to where? Charlie?
From -3 all the way to 5.
From -3 all the way to 5. Would it keep going?
Yeah.
It would go on forever and ever and ever, right? So the domain is x is greater than or equal to what? Not -3. So it has a discrete start point, but it doesn't have an end point. Get that? So the domain is, you would say x is greater than or equal to, they probably want you to write it in set builder notation like this, x bar, where x is greater than or equal to -3. Okay? What's the range? Where do the y values go from? Where do the y values go from? Where did what? Nick?
Is it from 0 to 2?
Not just to 2. It'll keep going up. It looks like it goes up and up and up and up. So how would I say that? 0 to what?
0 to infinity.
Yep. 0. You could write it like this. 0, including 0, up to infinity. Like that. Or you could say y bar, like that, where y is greater than or equal to 0. So that's in set notation. This is in interval notation. Okay? So the range is 0 to infinity, or 0 to infinity written this way or this way. So again, with the range, you could think of putting your flashlight here now, right? Here's my flashlight. I could probably draw a better flashlight over here. Here's your flashlight. Here's the switch on the top. That's it. And so if I shine light on this thing, the projection onto the y-axis, would have to bring the flashlight back over here and show that the projection onto the y-axis would go from 0 up to infinity. You get that? So I could have to take my flashlight on this side and then move it onto this side and show where that shadow would go onto the y-axis. Yeah? Yes? No? Sorry I got to teach you math, but that's my job, you know. Sorry if you're a little bored, but got to learn it. Okay? And there's a few notes to get through this stuff. Okay? And you'll have time to work. Who could tell me the domain? We're getting there. We're getting there. Domain. This is a tricky one. Okay? Think of where would the x values go from where to where? X values would go from where to where? Meadow.
Wouldn't it be like infinity?
Yep, it would be from negative infinity up to positive infinity, right? Because this goes out, even though it might go out slowly, it's going to keep going out forever and ever and ever in the x direction, right? This would go in the negative x direction. This one would go out and out and out forever in the negative y, in the positive x direction, right? So you could write domain negative infinity to infinity, or you could write it like this, bracket x, bar x goes, x is between negative infinity and less than positive infinity. So it's in like that, okay? How about the range, which is a little trickier on this one, okay? Anyone tell me the range, that one? Katira,
It's
less
less than or equal to 4.
than or equal to 4, that's right. Y is less than or equal to 4. Do you see why? Because the highest it ever goes is 4, right? It's never going to go above 4. So if I were to project the shadow of this thing, it would land from here down, right? Y is less than or equal to 4. Or you could say negative infinity up until I get to 4, close bracket, curly bracket, the end. Okay? Moving on. Couple more. Are there more? How about this one? Domain. Domain. What do you think, Tate?
Is that arrow down there?
What do you think, Ian?
Negative infinity to infinity.
Yep. X goes from negative infinity to infinity. Right? Negative infinity up to infinity. Oh, it's hard to draw those. How about the range? How about the range? What do you think, Gia? What y values can I have?
Would it be negative infinity to infinity again?
Yes, it would be. Very good. Okay? It would be negative infinity to infinity again. Okay? Negative infinity to infinity, because y goes all the way down forever and all the way up forever. Right? So that's an example where the domain and range go on forever and ever. Okay? Let's see if there's more. Function machine, you don't have to draw a picture of this, but a lot of times I use this as, yes, you have to copy this picture right now. I'm just kidding. Okay. Hey, Hannah, do you ever go to the vending machine?
No.
No? Okay. Who's gone to a vending machine? Okay. What do you get out of the vending machine? What kind? What's your favorite thing?
Dr. Pepper.
Dr. Pepper. How much does it cost?
150.
$1.50. Can you put in 5 quarters?
No.
6 quarters, right?
Yeah.
You can put in 6 quarters in here, right? So if this is your what button do you push? Do you know? I don't know. Maybe it's like the D7 button or something like that, right? Yeah. So can you put in 6 quarters? 6 quarters and get out a Dr. Pepper? If you push the D7 button? Yes. So I can put 6 quarters in here. I'll get out my Dr. Pepper. Delicious. Okay? Right? But can I put in a dollar bill and 2 quarters?
Yeah.
And push the same button? Will I still get out the same thing?
Yep.
That's an example of a function, right? I probably couldn't put in pennies, but I could probably put in 15 dimes and it would work. I could probably even put my credit card in, right? And it would work. So that's an example of function. I could take all these different things and put them in there, right? But if I push the same button, I'm only going to get out one thing, right? And that's a function. I'm not going to get out, if I push the T7 button, I'm only going to get out a Dr. Pepper. I'm not going to get out, what? A Diet Coke, because then I throw up. Diet soda makes me sick. Most soda makes me sick. No, I like Coke. Don't tell anybody that. So that's another example. I'm just going to skip over that one. And then function note. Oh, we got more? Oh, my God. Sorry, guys. You want to take a break? Okay, let's hit pause.
I like it. Keep going.
Well, let's just take a 5-minute walkabout, okay? 5-minute walkabout. Okay? You can just walk around, chat. Pause, okay? And we're gonna hit play. So, whoops, 1, 2, 3, 4. Okay, so function notation, okay, this is important for you to know. F of x, this means f of x. Have you guys seen this before? Oh, you have seen this before? Okay, so f of x, whoops, sorry. F of x does not mean f times x. It means take whatever x, it means f is a function of x. So if I take 5 and plug it into this function, I get out 11, okay? I get out 11. If I take 8, and if f of 8 means if I take 8 and plug it in there, 2 times 8 is 16 plus 1 gives you 17. If I take 2 and plug it in, I get out 1. Yeah, easy enough. The f of x means that's what I get when I plug in that number into the function called f. Sometimes the function is called g. Sometimes the function is called h. Sometimes the function is called a, and so on. Okay? So let's look at this function. Who can tell me, here, we'll make it exciting. We'll give you points. Who can tell me what is f of 4? F of 4. Go ahead, Jessica. 19. Is that right? 3 times 4 plus 7 is 19. Yay. Han and Bear. I'll give you bonus points one of these days. I'll put them in. What's f of negative 1? Go ahead there, Katira. You're on a roll. 4. Well, would you stop? Remind me in 4 hours. Okay, postpone. Okay. What did you get, Katira? Sorry. What did you say? 4. Is that right? Yes, because that's 3 times negative 1, right? Plus 7 gives you out 4. Okay? F of x plus 1 is a little bit trickier. Okay? So what do you do with something like this? You take it and you plug it in for x. Okay? Which seems kind of weird, but you plug in x plus 1 for x. So f of x plus 1 looks like 3 times x plus 1 plus 7. And then you simplify. So you have to distribute through, right? So you get 3x plus 3 plus 7, which gives you 3x plus 10. Yes? Who can tell me what f of 2x is? F of 2x is? Amanda.
6x plus 7.
Do the bomb. Okay? 3 times 2x plus 7 equals 6x plus 7. Very good. Okay? You get that? So f of means take whatever that is and put it in for x. Okay? All right. Next. We don't have to do every one of these, do we? Okay, good. Let's just do, what would g of n be? G of n. Anyone? What's g of n? So what you do the same thing. You take n and you plug it in where x is, okay? So what would I get if I plugged in n into this function? What would I get? Someone else. What would I get if I plugged in n into this function? 2 n to the second minus n. Very good. Okay? Chase. Right? G of n is just this. Right? You just plug in an n. G of 3 minus 4 says first you plug in 3 to the function, and then you take away 4 from that function. Let me do that one. G of 3 minus 4 would be 2 times 3 squared minus 3 minus 4. Because this is G of 3, right, minus 4. So this one's kind of complicated. So that gives you 9 times 2 is 18 minus 3 is 15. Minus 4 would be 11. See the way that worked? That's tricky. Okay? Uh-oh. H of 2, plug in 2. H of a plus b, plug in an a plus b everywhere you see x. Okay? Let's just do h of a plus b would be 3 times a plus b minus 4 over 2 times a plus b plus 5. Okay? Can I move on? And you would want to distribute and simplify. Well, in that case, I don't know if it's even worth distributing. Okay? You're done at that point. Okay, Cole? Can I go on? Okay. Why do we need functions? Whenever one thing depends on another, you have a function, right? So I've been sick the last few days. Take the thermometer, stick it in my mouth, okay? That thermometer doesn't know what the temperature is. It knows the amount of heat that it senses. But there's some function that scientists build into that thermometer to tell it, well, if I feel this amount of heat, then I plug it into this function and I show a temperature of 102 degrees or something. Uh-oh, this person's sick. That's a function, right? My thermometer is a function, right? Because if I'm normal, if I feel normal, I put it in, it senses an amount of heat, and it translates that into a Fahrenheit temperature. If you're in Europe or something, right, doesn't it translate it into a Celsius temperature or something? So it would have a different function depending on what country you're in, you know? If you're on the, if they just discovered like there's water on the moon, or not on the moon, on Mars, okay? And so the little green people live there, they probably have different functions, you know, to play basketball and stuff than we would have. Like they probably have stronger legs or something because there's a lot more gravity there. Do you know there's little green people on Mars? They just had that in the news yesterday. Yeah. Donald Trump said there were. I believe everything he says. Okay. Okay. So anyway, area of a circle is an example of a function. Okay. So a of r means so the area is a function of the radius. So if I were to plug in a 5 in here, I would get an area a of 5 is equal to pi times 5 squared. Okay, which means that the area of a circle of radius 5 is going to be 25 times pi, right? Okay, so that's an example of a function that involves area. Here's an example of a function that involves money, okay? How much money you make depends on how much you get paid per hour, okay? So another example of a function, okay? And then another example of function, height and time. You see me keep writing little things on here because I want it to record, if I don't write something on there, it won't record this with my slide. Hey! Yippee! Okay, let's see. Yeah, finally. Yahoo. Wahoo. Finally. Okay. Okay. So we're going to be done for now. Okay? And you can